I find a barrier to answering a lot of graph questions is not knowing what the vocab means. So I'm going to go through loads of vocab. Let's go for it. This middle bit here, 0, 0, that's the origin. This line across here is the x-axis. This line here is the y-axis. That's a line, which you could also say is a straight line. But, you know, we don't have to say it. We could just say line if we like. Straight line, line. This is a curve. Oh, I could draw a curve, and oh look, at this point here, it's kind of a maximum because it kind of goes up, and then it goes back down again. It goes up to here, and then it goes back down again. So we could say that's a maximum, and here is a minimum because it's kind of at its lowest point, and it starts going back up again. Now, it is lower here, but what this is kind of called, the full name is a local minimum, but we kind of never ever say that. I almost never hear someone say that. And they're both known as turning points, a minimum and a maximum. Oh, two lines may intersect. Obviously I mean straight line, and a curve and a line could intersect as well, who knows, or two curves. Okay, oh, the words range and domain. Now the domain, I always think of, you might be familiar with the fact that a domain kind of means your home. It's where you live. So I always think of that's what you start with, because you always start with the next value. And then imagine like if you've got like a farm, often it's also called a range, which is just like the land that you own around your house. So maybe you go out into the range, you go ranging. So that's why y is the one is called the range, because that's what's calculated. That's how I think about it. I don't know, whatever. Anyway, let's do we'll maybe do some examples of that later. The blue thing is a circle. That thing there. The point A is inside the circle. Notice I've drawn a cross and then labelled the cross, and that's how I generally mark a point. That's how a lot of people mark a point. And this brown line is a tangent to the circle because it's just touching but doesn't go into. This is a tangent to the curve. It's touching the curve but it doesn't cross it. You could also say that the gradient of the tangent is the same as the gradient where it touches the curve. Let's keep going with the vocab. This graph has an asymptote. It gets closer and closer to the x-axis but never touches it. And that is what asymptote means. To get really close to something. Like you could say it's getting infinitely close, if you wanted to use that word. This graph has two asymptotes. Very unusual graph, this. You can see it's kind of goes up there with a local maximum and then a local minimum, and it goes up there. But we don't generally say local, so that will be a maximum, that will be a minimum. Anyway, but the point is, here it's an asymptote, so it gets very close, and you could say it gets infinitely close, but it never crosses that dotted line. And often we use dotted lines. That is the standard way to indicate asymptote is happening. Right, let's go with domain and range again. So this is the equation y equals x squared plus 3. What's the domain? The domain is what x could be. So the domain you could write as x is anything. And the range, well, that's what y could be, because that's what we calculate. I always think because that's where you explore to. And that's just y. Well, y is greater than or equal to 3, and that would tell you all the possible values of y. Let's do another one. What's the domain and range of y equals minus x squared? Well, again, x can be anything along here. So the domain, x can be anything. And the range, y is less than or equal to 0. Oh, what's the domain and range of y equals x? Well, the x can be anything and y can be anything. So the domain is x can be anything, the range is y can be anything. This is a line, yeah? Could also call it a straight line. It's flat, it's horizontal, and it has a gradient of 0. Bit of a question here. When is y equals x bigger than y equals x squared. So I've drawn them both, and I've indicated with red where y equals x is larger than y equals x squared. I like that question. I think it just gets you thinking about them a bit. When is y equals x plus 3 greater than 4? Well, if that's 4 there, then, well, it's this bit that I've coloured in red. So when x is greater than 1. That describes that there. I've barreled through that really fast. This is particularly, I've designed this, all my videos are designed with my students in mind, but in theory can help anyone. And this was if you're kind of getting comfortable with grasp, you're just like, oh, I just want to run through loads of example vocab just to understand it a bit more. So hopefully that was helpful.